Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 145. It says binary tree post-order traversal. So previously we have done videos on pre-order, in-order and level order as well. I'll leave a link at the description and this is a continuation to it. So we are going to cover all the traversal algorithm before we move on to the other problems. So it says given the root of a binary tree, return the post-order traversal of it nodes values. Okay. So here are some examples given, and I guess they have also given us a constraint over here that it will be of between the range 0 to 100, and we'll have minus 100 to 100 values in the node. Though it doesn't matter to us what values it contains. So it says that we should do it in an iterative way, and we should not use the recursion and call stack for the same. Before we move any further, let's understand what is a post-order traversal. So in post-order traversal, what happened is we start going towards our left as much as we could, and once it is done, then we start going towards our right. And once we have done exploration of both left and right subtree, we are going to process the node, or we'll call that we'll process the root, right? So in this example where we have a node like 1, 2, and 3, we'll start from the root, which is 1, and we'll try going its left. There is nothing to its left, so we'll go to its right. So as soon as we came to the right, it becomes our current node and we try to go to our left. And from left, we cannot go any further left or any further right, right? So we'll process it, means our processing includes just printing the value of it. So we'll print a 3 and we are done with the node 3, right? We come back to 2. So left of 2 is done. We'll try going to its right, but there is nothing to the right. So right is also done. We'll consider it done and we are going to process this node. So processing means we are going to print the value once again. And then we come back to 1 for 1 left and right both is done. So what we are going to do is we are going to process the node. So we are going to print the value again. So we'll end up having a result like 3, 2, and a 1. So here also you can see in the example that we have the similar result 3, 2, and 1. So yeah, we'll look into the solution in much more details, but as I always recommend, do give it a try yourself before you look at the solution. So this is once again a very important traversal algorithm that everybody should need to know. And we will head over to the board and check out the solution. Don't miss out the solution. Understand all of them. I would highly recommend that you go through all the videos for the traversal in this channel, and it would be of great use for you. So let's move over to the board and let's check out the solution. So I've taken a tree over here. This is the same tree that we have used earlier as well for the in-order and the pre-order example, and we are going to use the same tree for the post-order. What happens in a post-order traversal is we try to go left, as much left as possible, and then once we are done with the left, then we try to go to the right subtree. So this is the right part. And then we process the node or visit the node, whatever you say. So processing includes printing the node for us in this case, and in the code it will be to add it to the array list, right? So we are going to see how this entire algorithm works in recursion, and we are going to build a call stack and see how it all uh, comes into effect. So I have taken a call stack over here, and we are going to see how we are going to use this call stack to come up with the answer. So we'll take the current context over here. The current is nothing but our root node in the beginning. So we will have one as our current, or which is the root, right? So what do we do from here? We go towards our left. So going to the left means we are talking about this node 2 over here. So we'll call the same function with the left child. So what will happen is the current function, which is a 1, will get pushed into the call stack. So don't think that we are pushing the value 1, but the instance of this method is getting pushed inside it. And what happens is 1 is replaced with a 2 over here. So 2 again tries to go towards this left. That's the first statement of our code. So what happens is 2 gets pushed inside the stack over here, and 4 comes into current. Since 4 doesn't have a left or the right, so these statement will not be applicable for it, because in the real code we'll have a null check before calling these functions, right? So we are going to process this node 4. So what does processing means? For us, the processing means we are just printing the value. So we are going to print 4. So the instance 4, the node 4, is done with all the three statement over here. So node 4 is completely done, right? It has tried its left, right, and it has printed or visited its node, and so it's going to go out. And 2 will pop back out from the call stack since it's on the top. So 2 went inside the call stack because of this line, the first line. we try to explore the left. So now we'll try to explore the right once again. So in the right we have a 5, so 2 will get pushed again inside the call stack over here, and what will happen is 5 will come into the current, right? So again 5 does not have a left and right, so these statements are not applicable, so 5 is going to get processed. So processing once again means printing the node over here. So 5 is completely done. So what will happen is 2 will pop out again, and once we pop out 2, unlike the first time it went for this line, this time it went for this line, right? So the only statement remaining for 2 is to visit the node, and in our case it is just about printing the node. So we are going to print 2, right? And then we are going to pop out 1 from the stack. So for 1, we saw that the left, this statement is completed, this is still pending, right? So 1 will now call its right child, which is a 3, and put himself back into the stack, right? Now 3 will try to go to its left, there is no left, so this statement will not be executed, but it has a right. So what will happen is 3 will get pushed inside the stack over here, and 3 will be replaced by the 6. So for 6, what we see that it does not have a left and the right, so it will just go ahead and process it itself. So it will print its value, which is a 6. So 6 is completely done. So what will happen is 3 will pop out from the stack once again. So 3 has completed both this statement. The only thing remaining is the visit node. So 3 is going to print itself, and 3 is completed. And now 1 will get popped out again. And for similarly for 1 also, we have seen that these two statements has been completed. So only thing pending was to print the value. So we are going to go ahead and print the value. And what will end up over here is nothing but our post order traversal, right? So this is our post order result over here, right? So if you see for every subtree, like if I take a subtree over here, so let's take about this subtree, which has a root starting from 2, right? So what will happen is you see that the root will come at the very end. So this is our result if that is the subtree, right? So this will be our result, this part. So you see that the left is processed first. So 4 came first, then the right, so 5 came, and then the main root of the tree. So the 2 came. So the root for any subtree will be at the very end, and the leftmost node will be at the very left. So what we can say is that this is our leftmost node, and this is surely our root of the tree or the subtree. Similarly, if you check for the main tree also, you will see that the root is at the very end and leftmost node continues to be 4. So 4 is at the left, right? This is how this entire post order traversal works. So we are going to understand that how we are going to do this same thing iteratively, right? So the solution that we are going to look over here is a dual stack solution, right? We are going to use a double stack over here. It could be two approaches over here. One is using double stack and the other is to add it to your list and then you reverse the list at the end, right? Will be the result stack, and the other we will call it the processing stack, right? We have a current and the current points to your root node, right? So we are going to put that. So this node is yet to be processed, right? So we are going to put this node inside our processing queue, what we can say, but it's a stack. I don't want to say queue and confuse you guys. So it's just a stack. It's a processing stack. So one is not processed yet. So I put it inside, and let me put the algorithm over here at the same time so that it becomes easier for you to understand. So the first thing that we are going to do is add root to the processing stack. So the second step is that we are going to iterate until the processing stack is empty, and it's never going to be empty because as we go on, we are going to continuously add the left and the right child to it until we hit a null. So until the entire tree is complete, this is never going to be empty, right? So now what we are going to do, if you remember, that our root always stays at the very end in a post order traversal. So what we do is we take this one that we have already over here. So the first thing that we do is, so I'll call it p stack for simplicity. I don't have to write it again and again. And let's say we get it in E, right? So we are going to add this to the result stack, right? We are going to put the value of it inside the result stack. So we are going to put this one into the result stack. Why we are putting the root at the very beginning is because we are going to take the result out from this result stack and put it back to the list. And if you remember, if we take things out from a stack, the first entry to go in comes out at the very end, right? So 1 will be at the very end for us, right? And what else we are going to do is we are going to add to the processing stack the left and the right. So what will essentially happen because of the statement is we are going to add the left and the right. So you see that again over here, what is important for us is that we maintain the right order. The left goes first and the right, because if we take out things, right should come out first and then followed by the left. So what happened is we popped out 1 at this state, and we added it to the result. So it came here, and we added the left and the right node of the 1. So 2 and 3 was added in the process. Now we are going to pop out things back from the stack again, right? So let's get out 3 from the stack, because that's the next element for us. So as we get the 3, what happens is 3 goes inside the stack, right? That's what we do always. And we add the 3's left and right to the stack. So 3's left is not there, so right is a 6, so we are going to add the 6 over here, right? So 3 is done, so we pop out again and we get a 6 over here, right? So 6 is again added back to the stack, and there is nothing, so we can't proceed any further. So next time we do a pop, what we get is a 2. So we get the 2 over here, and now what we are going to do is we are going to put 2 inside this process result stack and add 2's left and right to the processing, right? So we are going to pop again, and this time when we pop, we get a 5, right? And what we do is add the 5 to the stack, and 5 doesn't have any left and right, so nothing to be added. So we pop again. What we get is a 4. Sorry, this 2 was also done. So we get a 4. So we add the 4 over here, and we are done with this stack. Now this stack is empty for us, right? And now if I take out this result over here and start putting it into a list, right? So let me put that algorithm part over here. So let's say we are going to iterate until the result stack is empty, and let's say we have a list over here which is of type integer, and let's say it's called res. So let's say what we do over here is to add to res, and what we do is we do a result stack dot pop, right? So what will happen? Things will start coming out of this stack. So what will come out first? 4 will come out and get inside this list. 4 is gone. We get a 5. Next, 5 is gone. Then we get a 2. 2 is gone. Then we get a 6. 6 is gone. Then I get a 3. 3 is gone. And then we have a 1. So we just got the same result as this guy. What we just did is we stored the result in a reverse order. So that's why you see that we put the left first and the right, because we are using double stack. So if I take the right and process the right first and then put it inside the other stack, and then I put the left on top of it. So when I take out, so what happens over here is visual, like let's do a visualization. So let's call it root, left and right. And let's say we have 2 stacks over here. This is my result stack and this is my processing stack, right? So what we did was we put the root first over here and we started, right? So now we get the root out and we processed it and added it to the result. Now we put the left and right. Our target is to do left, then right, then root, right? So what will happen is we need the left first and the right. So if I put it like this over here in the reverse order, so when I take out, I get the right first. So when I get the right, I put the right over here first. And then what happens? I get the left and I put the left over here. And now we are taking and popping things out from this stack and we are building our result. So what will happen is left, right, root, right? Because of the nature of stack. So what will happen is this and this will become equal, right? So what we are going to do is we are quickly move over to the Leetcode and check out the solution for the same. Okay, so at the end, what we need to send is an integer list. So let's build that first and let that be an array list. And what we are going to do is we are going to populate it and send it back at the end. And also we are going to return an empty list if we see that we are passed with a null, right? So in this case also we are going to return the result, right? So now we have talked about two stack over here. So let the both be. So I'll take a stack of three nodes over here, and we need a stack of integers that we are going to reverse at the end. So our root has not been processed yet. So what we should do is we are going to add the root of this tree to the stack, and we are going to say that we are going to continue processing until the processing is empty, right? So here we are going to pop things out. And now we are going to check if left is not null, then we are going to add to the processing stack. And similarly, we are going to do the same thing for the right as well. So let's get that done. Okay, so at the end of this loop, what will happen is we'll have our nodes inside the value stack and our processing stack is empty. Now, what we are going to do is we are going to iterate until the value stack is empty and we are going to pop things back from this stack. So until it is not empty, we are going to iterate and we are going to add back to the result dot pop. Run and check. Yep, it's good. So let's do a submit and check for a wider range of test cases. Yep, we are better than 100% of all the submissions, which is pretty cool. So I hope you understood the solution over here, whatever we have discussed and explained so far. You have understand the simplicity of the solution and why we are basically using multiple stacks over here in order to come up with the result, right? So yeah, this is the algorithm all about. Now talking about the complexity. So basically all your element will be touched over here the way we are traversing, right? We'll have all the element touched, right? So you will have a runtime of order of n, right? Where n is the total number of nodes. We have an extra loop over here. This is also going to contribute to order of n because we are processing, we are coming up with the result right over here. So a post order traversal should include all the nodes. So yeah, it will be order of n. So order of 2n, which is equivalent to order of n. And coming back to the space complexity over here, so we are building multiple stacks over here, right? And in the worst case, what will happen is you can end up holding all the nodes that's present for your tree into your stack space, right? So either your node will be present on this stack or in this stack. It will not be present on both the stack at the same time, right? Either it is here or here. All could be present here or none could be present here. So if you add them at any time, you'll have the total number of nodes. That's the maximum that's going to be. So your space is also going to be order of n. So you will require, in the worst case, you'll require n spaces. So if you have a tree which is skewed to the left, so what will happen is your stack will have all of these nodes present inside your stack, right? And again, for the other stack also, for this result stack, what will happen is you will eventually store all the nodes here, right? It's a good case or the bad case, whatever case it is, you will end up storing all the nodes over here. So again, in the worst case, you will have a order of n for that stack as well. It is again going to be order of uh, 2n, right? We can drop the constant and it still becomes order of n, right? So yeah, this is the solution all about. Do let me know what do you think about the solution. Do like and subscribe if you think the solution was helpful for you and I should be creating more videos down the line. It would be of great encouragement for me as well. If there is any particular problem that you want me to solve, it's an online problem, offline problem, whatever problem it is, or any concept you want me to create a video on, do let me know. I'll surely give a try. It's good that I have started hearing from people in Facebook or in different platforms where people are approaching me with problems to solve for them. And definitely I will create videos for them as well down the line. So let's have more engagement on this channel. Let it be interactive. I just don't want to create videos on whatever I think I should be creating, but I should be creating videos on what you want me to create so that even I get to learn new things. I need to explore new things along with you. I should also be growing, I feel, at the same time. So do let me know and let's keep it as interactive as possible. So yeah, I'll keep this short. So that's all from this video. See you guys soon again and have a great day. Bye bye.